Hi everyone, welcome to Unprocessed Math. In this lecture, I'm going to talk about U-substitution with a linear function. And I'm going to assume that you're familiar with the substitution method, and if you're not, I suggest you to watch my previous video on U-substitution method and watch this video after. So let's get started with an example. Suppose we want to integrate the function sine 3x plus 5. And notice that 3x plus 5 is a linear function. What's a linear function? A linear function looks like some number multiplied by x plus another number. And you can integrate this function the same way that you would integrate sine. Derivative of sine is minus cosine. So derivative of sine 3x plus 5 is going to be minus cosine 3x plus 5. And all you need to do is to divide by the coefficient of x in your linear term, which is 3. And now I have the integral. And you know that you can add a constant at the end. So the antiderivative of sine 3x plus 5 is going to be simply minus cosine 3x plus 5 divided by 3. And the idea is that you can integrate this the same way that you integrate the sine function, but after you're done with your integration, just make sure to divide by the coefficient of x in your linear term. Let's look at another example. Suppose we'd like to integrate ax plus b to the power 100. And notice that ax plus b is a linear function. It's some constant multiplied by x plus some other constant. So I can integrate this function the same way that I would integrate the function u to the power 100. Integral of u to the power 100 is u to the power 100 plus 1 divided by 100 plus 1. And so the integral of ax plus b to the power 100 is going to be ax plus b to the power 100 plus 1 divided by 100 plus 1. And after we are done, we divide by the coefficient of x in the linear term. And that's where this a comes from, plus some constant. So you see, we can directly write the antiderivative of this function without going through the steps of U-substitution method. Let's look at another example. Here, I want to integrate 1 divided by minus 2x plus 5. And notice that minus 2x plus 5 is also a linear term, a linear function. So I can integrate this function the same way that I would integrate 1 over u. Integral of 1 over u is natural log of absolute value of u, and so the integral of 1 over minus 2x plus 5 is going to be natural log of minus 2x plus 5, but we remember to divide by the coefficient of x in your linear term, which is minus 2. And you can add any constant. So you see, I can directly write down the antiderivative without doing a formal substitution. Let's look at the next example. So here, we'd like to integrate the cube root of 3x minus 7. And again, notice that 3x minus 7 is a linear function. I can write it as 3x minus 7 to the power 1/3. And we can, since this is a linear function, we can integrate this function the same that we would integrate u to the power 1/3. Using the power rule, it's going to be u to the power 1/3 plus 1. And notice that 1/3 plus 1 is 4 over 3. So using the power rule, the integral of u to the power 1/3 is u to the power 4 over 3 divided by 4 over 3. So integral of 3x minus 7 to the power 1/3 is going to be 3x minus 7 to the power 4 over 3 divided by 4 over 3. But remember that we also need to divide by the coefficient of x, which is a 3. So the the antiderivative of this function is going to be given by this function. And now you can just simplify this. The 3's will cancel, and you get a 4 in the denominator, and this is your final answer. And we always add this constant of integration. In this example, I want to integrate 1 over square root of x minus 3. Every time that you see a radical when integrating functions, it's a good idea to write it as a fractional power. So I can write this as x minus 3 to the power 1/2. And then this is 1 divided by x minus 3 to the power 1/2, and I can write it as x minus 3 to the power negative 1/2. And now this is, I can apply the power rule to find an antiderivative. So the exponent here is minus 1/2. And notice that minus 1/2 plus 1 is 1/2. So using the power rule, the antiderivative of this function is going to be x minus 3 to the power minus 1/2 plus 1, which is 1/2 divided by 1/2. And remember to divide by the coefficient of x, which is 1 in this case. And so this becomes 1/2, and instead of dividing by 1/2, you can multiply by 2, and this simplifies to 2 times x minus 3 to the power 1/2 plus some constant. So you see that, again, I'm doing this integration without doing a formal substitution. Let's look at this last example. So here we want to integrate the exponential function so that it is e to the power 1/2 x minus 4. And again, notice that 1/2 times x minus 4 is a linear function. So I would integrate this function the same way that I would integrate the exponential function. The antiderivative of the exponential function is itself, but I need to divide by the coefficient of this linear term, the coefficient of x in the linear term, which is 1/2. So the antiderivative is going to be e to the 1/2 x minus 4 divided by 1/2. So you see what I'm doing here is I'm integrating this the same way that I would integrate e to the u. Integral of e to the u is e to the u. So integral of e to this linear term is e to the same linear term, but we keep in mind that we have to divide by the coefficient of x, which is 1/2. Now, instead of dividing by 1/2, you can multiply by 2, and this becomes your final answer. And you can always you should always add the constant of integration. So you see, whenever you have linear terms in your function, you can actually do the integration without doing a formal U-substitution. For additional practice, you can take a look at section 6.1 of the Apex Calculus 2 textbook. And for any additional help, visit mathematicians.com.